All right, kids, here comes section 6.5. We're looking at the behavior of accumulation functions. A lot of this is summarizing things that you already know. So we are looking at this right here is known as our accumulation function. We saw that in the last section. But the really important thing to remember is right here, that capital F prime of x, the derivative, it's actually the antiderivative, it equals your original function. So this piece here represents what your original function was. We know today's lesson is a review of a lot of things that we've talked about in Unit 5, yeah. We will analyze the first and second derivatives to understand the behavior of graphs. So we know a graph is increasing when the derivative f prime of x is greater than 0. But since f prime of x and f of x are the same thing, we know it's decreasing. Now this is in terms of this accumulation function. They're talking about the f of x in that location. If I look at decreasing, same kind of idea. Again, if this confuses you that it's f of x, we're going to do a bunch of problems in just a minute so you can see what this looks like. We know it's decreasing when it's less than 0. We know we have a maximum when the first derivative changes. Now think about it, maximum, it changes from positive to negative, increasing to decreasing. We know we have a minimum, vice versa. Right? We know we have concave up, comes off the second derivative, right? Second derivative is greater than 0. And concave down when the second derivative is less than 0. And a point of inflection when the second derivative changes signs. That is nothing new to us. All right, so here we go. Here's why you need to kind of have this extra stuff here. Let g of x be the integral from a to x of f of t dt, where the graph of the function f is shown. Now you need to know what the heck you're looking at. If it's f, then f represents g prime of x, right? It's the derivative. The integral is the derivative. How can I say this right? Remember that they're inverses of each other, so the derivative and the integral undo each other, and that's what this is. You've got the derivative and the integral undo each other, so you're left with just what f is. So you're really looking at f, which is g prime of x. All right, let's see if we can figure these things out. And it's all because of this. G prime of x would be what the derivative of this is equal to that function. All right, so here we go. We're looking at these things. Now I'm going to use a couple colors just so you know we can highlight what we're looking at and what the answer actually is. So I have a relative minimum, and I know that the relative minimum is when my derivative, in this case g prime of x, changes from negative to positive. We just said that in the chart up above, that the derivative changing from negative to positive. But g prime of x is actually f of x, right? G prime of x actually represents the original function. So I'm looking at this function. Where does the function change from negative to positive? And that would be this location right here, right? Because to the left of it, it's negative, below the x-axis. To the right, it's positive. So we have to estimate about where that value is. So it's at x equals, I'm going to say 5.4. Where is it a relative maximum? Now that's going to be when g prime of x, which is f of x, changes positive to negative. All right, so let's look at the graph. The graph is of f of x. Changes from positive to negative, that would be at 3. Where is it concave up? Concave up would be g double prime of x, which is f prime of x, right, down a derivative. And so therefore I'm looking at slopes, right? And I need a positive slope at that for concave up. So where is the slope of this graph positive? Where is it increasing? And we can see that here it is steady, here it's negative, here's where it's positive, 4 to 6. So in the interval from 4 to 6, that's where it's concave up. Concave down's got the same reasoning. You've got g double prime of x, which is f prime of x, and I want to know where the slopes are negative. Where are they decreasing? And that would be between 2 and 4. And that's it, because everybody else is either increasing or positive. A point of inflection is when your second derivative, which is your first derivative for this graph, and so therefore I'm looking at the slopes again, right? When they change positive to negative or negative to positive. I'm just going to say change signs. Now, do you know where that happens? Can you tell from your concavity answers for C and D where that happens? It went from concave up to concave down where? At x equals 4. And you can even tell the slopes are negative, slopes are whatever. So at x equals 4, that's your answer either way. Here's where it gets a little dicey. And we're going to this is going to come up in several problems we're going to look at in this section. But they're giving you a location for the beginning of this. If g of 1 is 5, what is the maximum value of g on the interval from 1 to 5? Okay, so here's what I've got to do. This has a starting location. See how my interval starts at 1? At 1, it's 5. And you're going to add on the integral from 1 to 3. Now I'll talk to you about why that's 3 in just a minute, of f of t dt. I want to find the maximum value. All right, here's where this 3 is coming from. This 3 is your maximum x value from part B. It's the maximum x from part B. That's where that upper limit comes from. And so I know integrals, how I evaluate them is by area. So what is the area from 1 to 3? Well, let's look at that. If I'm going from 1 and stopping at 3, then I'm looking at this area right in here. Can I count boxes? Probably not, unless I did an estimation. But I can literally use my geometry to be able to figure this out. So I have the area, I can use a trapezoid, right? Make it simple. So the area is going to be 1/2 the base, well, the width of that is 2, times base 1 plus base 2. Well, base 1 is 1, base 2 is 2. Is that true? Base 1 is 2, base 1. Yeah, I get a value of 3. Okay, so my 2's cancel out. This gives me 3. And if I have 5, can you still see me? Almost, maybe not. Plus 3, I get an answer of 8. So kind of strange how that works, but that's because your maximum value for x was the x value of 3. And that's what you're putting in there, and then figuring out what the area is. All right, that's page 1. Let's go page 2 and Number 2, same graph, right? Same situation, except now they've changed things up. And they've made my upper bound an x over 2 plus 5, which gets a little bit more complicated. But the question says, where the graph of f is shown at the right, find the x value where g has a relative maximum. Well, relative maximum happens when g prime, when the derivative changes from positive to negative. So how can I find g prime on this guy? They gave me the f. G prime is going to equal the derivative. Remember this, I'm going to take this value and plug it in for the t. So f of x over 2 plus 5 times the derivative of x over 2 plus 5. Well, the derivative of, this is like a 1/2 x. So it would be times 1/2. And the derivative of 5 is 0, so you don't have to worry about that. Now here's where it gets a little bit, it's a little crazy. You know that this has a value of 3 right here, because we said that from the graph from the other page. So if I set this thing, if I want to find a maximum, where this is a maximum, I'm going to take this thing and set it equal to 0 to see where it changes signs. Which means that either 1/2 has to equal 0, and I'll come back to that in a second, or f of x over 2 plus 5 has to equal 0. In order for these two to multiply together to equal 0, one of them has to be 0. Well, 1/2 can't be 0. And I know that this thing equals 0 at 3. So my next statement is that 3 is where I have that x over 2 plus 5 maximum value. And so then I work on solving that out. This becomes a -2. They didn't give me much space. And then I can cross multiply, and I get an x equals -4. And that, my friends, is the answer to that question. A little crazy. I think I picked 2 problems. I know one of them is number 2. So in the practice problems, number 2, let g of x equal the integral from a to x of f of t dt with the graph of f shown above, right to the next. And a is a constant. Find the x values of g regarding each of the following conditions. So I want a relative minimum. So remember what you're looking for in the midst of these. If I'm looking for a minimum, my f of x is the same thing as g prime of x. F of x equals g prime of x. Now I'm not going to write the reasoning again. You have all those reasons that when we did the front page stuff. But I want to know where is, for a minimum, where is the derivative, or f of x, going from, for a minimum, from negative to positive. And the only place it goes from negative to positive is right here at 8. It changes from negative below the x-axis to positive above the x-axis. This one's an x equals 8. Where's the maximum? That's when f of x changes from positive to negative. That would be at 6. And again, the reasoning, we put all the reasons back here when we were doing this page right here. So if you're wondering what you're looking for, go back to what we wrote there. All right, concave up. Well, concave up is when the slope is positive. Where do we have positive slopes? Concave up, positive slope, 0 to 2. Constant slope, negative slope, positive slope. Positive slope from 7 to infinity. Concave down, where is there a negative slope? Negative slope was this piece, 3 to 7. Now where is it increasing? This one we might not have had on the other sheet. I don't think we did. Increasing, you're looking for above the x-axis, and decreasing would be below the x-axis, okay? So it did have a couple added little doodaddys in this. Above the x-axis is from 0 to 6. Any more? Yeah, 8 to infinity. Below the x-axis is 6 to 8. A point of inflection is a change in slopes. Well, the slope changes literally from, remember for points of inflection, it literally needs to change from positive to negative or negative to positive. So it can't go like, this is a change in slope, positive to 0, but it's not a change from positive to negative or negative to positive. So it's just at x equals 7 at this pointy place here where it changes slopes. All right, here's where the problems get a little harder. This is like newer stuff. You know that they give you an initial value of 2 is 1. What is the maximum value on the interval from 2 to 9? We just did a problem like this a second ago. So they're only looking at the section that goes from 2 to 9. So starting here and stopping at 9. So it's going to be 1 plus the integral starting at 2. But where was your maximum? My maximum's at 6. That is the value you put up here of f of t dt. All right, so I'm going to be 1 plus whatever the area is between 2 and 6. So let's look at areas. We've got a trapezoid and we've got a trapezoid. So the area of my trapezoid, let me change colors here. The area of the trapezoid is going to be 1/2 area of my trapezoid. The height of the trapezoid is 3. Watch your scale. Base 1 is 1. Base 2 is 1, 2, 3, 4. So I have 5. I get 15 over 2, or 7.5. And so the answer to my question is, put it here, 7.5, that's my area. Answer to the question is 8 1/2. Okay, see how you do that? I think the more you see them, the easier they get. And then the last one is kind of the goofy one. Also, I believe, like what we did with number 2 of the examples. This one, they want to know what h prime of x is, because it's a minimum, a relative minimum. So it's going to equal f of x over 2 plus 5 times the derivative of x over 2, which is 1/2. Derivative of 5 was 0. And I have to figure out where the minimum is. So that's going to be equal to 0. We saw before that either 1/2 equals 0, it doesn't, or f prime of x, or f of x over 2 plus 5 has to equal 0. So you're totally ignoring that 1/2. 1/2, maybe I'll say it over here, 1/2 can't equal 0. And what is the function value at where the minimum is? If I go back to my answers, the minimum's at 8. So I'm going to take x over 2 plus 5 equals 8. Solve it out. X over 2 equals 3. Cross multiply, x is 6. And there you go. That's your answer. Now I do believe that there is two. Oh, I'm fibbing you. There's 2 left that I wanted to look at. Number 3 is next on the list. This one is a calculator active problem. And as I look at it, it says, let f be the function given by f of x equals 1/10 to the x of sine of 1 over t dt for 1/10 to 1. Now I'm going to tell you, I'm not going to actually do the problem out on the calculator, but I'm going to tell you what to do. So you want to graph this thing. So you're going to work on the graph of this. But what the heck are you graphing, right? you're looking at this, I don't know what that means. Well, remember you take whatever this top bound is and you put it in for the t. So really what you're graphing is y equals the sine of 1 over x when you replace the t with the x. All right, that's not bad to put in your calculator. That's not a big deal. But what you want to do is realize that this should be your window, right? So you're doing your x min being 1/10, 0.1, and your x max being 1. So limit your window so it makes your life a little bit easier. And you want to know where the max is. Well, maximums happen when the sign changes, when it changes, oh, not an S, let's see. Positive to negative. So in other words, you want to find the 0 where that happens. Okay? So you're graphing in your graph y equals sine of 1 over x. Make your window just go between 1/10 and 1. And then you want to know where it changes signs. You want to find that 0 where it goes from positive to negative. And that should be your value. So that's my hint for number 3. And then finally, the last one, I really mean it, the last one this time. Number 7. This is a popular AP question. Very popular. So I'm looking at this thing, and I can see that the graph is a differentiable function shown if h of x equals the integral from 0 to x of g of t dt. Which of the following is true? Now remember, if you're looking at this, g of t equals h prime of t from the fundamental theorem of calculus, right? So I'm taking the integral, it undoes it, the derivative of the integral undoes that. So the derivative of this is actually that function there. So keeping that in mind, and you're looking at g of t, which is really the derivative. So the graph is of this thing. If I'm looking for comparison between h of 4, h prime of 4, and h double prime of 4, I need to figure out what those things are. H of 4 is equal to the integral from 0 to 4 of my function. So in other words, by the way, I'm only looking from 0 to 4. So I'm really only looking at this section of the graph right here from 0 to 4. I could shade it in and do, but you got the idea. Okay, so in other words, what the heck is that? Well, this represents the integral of this function, which is the area under the curve. Well, between the curve and the x-axis. What can you tell me about that area? So if I'm looking at this, I can tell that this area, I couldn't stand it. It needed to be highlighted. Okay. You can tell me that, you can't tell me well, I guess you could estimate what it is. But really all you need to know is the area is positive or negative, and you say negative because it is below the x-axis, okay? There's my h of 4. H prime of 4, now remember h prime of 4 is the same thing as g of 4, which means it's the coordinate, which means, what's the coordinate at 4? It's 0, 4, 0. Okay. And then I need to get to h double prime of 4. So now what am I looking at? If I'm looking at that, it's g prime of 4. Well, g prime of 4 is then going to be the slope at 4. The slope at 4, if I'm going to look at the slope here, what's happening with the slope of those tangent lines? They're all going to be positive. So can you put in order then your values? You don't need to know exactly what they are, like the fact that this area is negative. I don't know, negative what? I don't know, it doesn't matter. If I put them in order in an inequality statement, it always goes with the smallest first, okay? So that would be h of 4. We know that's a negative value. We know that the coordinate is 0, that comes next. That would be h prime of 4. And then we know that this is a positive slope, so that means that h double prime of 4 is the biggest. And that correlates with A. Very popular AP question. All right, that takes care of section 6.5. I will see you in class, but shoot me an email if you've got any issues or questions. See you then. Bye.